let's see what happens. Okay, so we're going to start with a simple example, and this uses a product rule. So if I have the square root of 3 times the square root of 6, so that's one of the worksheets involves things like this, but it's not going to be that simple, but it still involves that idea. So remember the product rule says if the indices are the same, see the square root, then I can multiply the radicands. 3 times 6 is 18. So this becomes the square root of 18. But here's a problem though. You have to simplify. So just don't leave the answer like this. You got to simplify if you can. So notice that I can simplify the square root of 18 because the largest perfect square that goes into 18 is 9. So this becomes the square root of 9 times the square root of 2. And so the square root of 9 is 3. So your answer is 3 square root of 2. All right, so that's the idea you're going to use on one of those worksheets. All right, let's get to number 2. So number 2, you have this now. You have 3 square root of 2 times negative 4 square root of 3. All right, so it's that same idea as this, except this time notice that this that's in parentheses, that's a 3 here, and that's the square root of 2. And over here, you have this negative 4 times the square root of 3. So it's kind of like saying this. It's kind of like saying I have 3 times the square root of 2 times a negative 4 times the square root of 3. That's what this is saying. So if you need to, now you're going to try and write this in a better way. I know that 3 times a negative 4 is a negative 12. And I also know that I can rewrite the square root of 2 times the square root of 3 as the square root of 6. 2 times 3 is 6. So this becomes negative 12 square root of 6. Now, I cannot simplify the square root of 6 because the only perfect square that goes into 6 is 1. So there's your answer. So that's all you do. Now, you didn't have to write it like this. You could most people will look at this and say, all right, I can say 3 times the negative 4 because this is multiplication right here. So 3 times the negative 4 is negative 12. The square root of 2 times the square root of 3. Since the indices are the same, I can write it as 1 square root just by multiplying the radicands together. 2 times 3 is 6. All right, that was number 2. All right, let's look at number 3. Number 3, I have 5 square root of 6 times a negative 5 square root of 2. So 5 square root of 6 times a negative 5 square root of 2. It's the same idea as what we just did here. So rather than writing it like this, let's just think about this. I have 5 times, see that's times right here, multiplication, a negative 5, that's a negative 25, right? Now let's do the square roots. The square root of 6 times the square root of 2, 6 times 2 is 12, is the square root of 12. So that's where I'm at. Now, the difference between this one and this one is that this I can simplify. See the square root of 12? I can simplify the square root of 12 because the largest perfect square that goes into 12 is 4. So this becomes the square root of 4 times the square root of 3. And then the square root of 4 is 2, so I get 2 square root of 3. Now that is just this though, so you got to be careful. So the square root of 12 is this. So now I'm going to say negative 25 times 2 square root of 3. And so now negative 25 times 2 is a negative 50. So I get negative 50 square root of 3. And so that's the answer. So you see, so you're going to say 5 times negative 5 is negative 25. The square root of 6 times the square root of 2 is square root of 12. And then simplify the square root of 12. So the square root of 12 is this. The negative 25 times 2 is negative 50. All right, number 4. Number 4, you have negative 6 square root of y. That's a y now. Times the square root of 2x. Okay, so that's what I have. So I have this times this. Notice though, see there's no number there. That's understood to be a 1. So let's kind of think about what we did here. 5 times negative 5. So negative 6 times 1 is negative 6. The square root of y times the square root of 2x. I can write this as 1 square root just by multiplying the radicands together. Y times 2x is just 2xy. And there's nothing else I can do. I cannot simplify this any further. So that's your answer. Number 5. Number 5, I have 3x square root of 3x, so 3x squared root of 3x, times a negative 2 square root of 21 xy. All right, now be a little bit careful with this one. So let's kind of look at this part here. 3x times a negative 2, see that? 3x times a negative 2 is a negative 6x. I can write that like this now. Now look at the square root right here. I can write this as 1 square root. So the square root of 3x times the square root of 21xy I can write as 1 square root. Now look at what you're doing though. You're going to say 3, this 3, times this 21. Use your calculator if you need to. That is 63. 3. Now it's this 3 here, not this 3. This 3 here. 3 times 21 is 63. X times x is x squared. And then y. So 3x, here's what you're looking at. So let me just kind of write it right here. You have the square root of 3x times the square root of 21xy. So according to the product rule, I can write this as 1 square root. 3x times 21xy. So that's what I'm doing here. So that's what I was doing. So 3 times 21 is 63. X times x is x squared, and then you're left with y. So now this is where you're at, okay? So now you got to ask yourself, can I simplify this part here? And the answer is yes, because you know you can simplify the square root of x squared, because 2 is greater than or equal to the index 2. And I know I can simplify the square root of 63. Or, well, can we? Let's see. 21 is 7 times 3. Yes, because what perfect square goes into 63? Look at 9. 63 divided by 9 is 7. So square root of 63, I can write it as 9 times 7. All right, so let's talk about this then. So I'm going to take this right here. I'm going to rewrite it right here. Square root of 63, x squared, y. So this becomes the square root of 63 times the square root of x squared times the square root of y. Square root of 63 is the square root of 9 times the square root of 7. Square root of x squared, that's just x. And then I cannot simplify the square root of y because remember the exponent is 1. 1's less than the index. So that stays the square root of y. But now I want you to notice this. The square root of 9 is 3, right? Now the square root of 7 times the square root of y is the square root of 7y. That's what that is. And then this x I'm going to put in front. So these 4 things, 1, 2, 3, 4, multiplied together is just 3x square root of 7y. So that goes here. So that's this right here. That's this. Okay? So I get negative, don't forget about the 6x, so negative 6x times 3x square root of 7y. So that's where I'm at. All right, so notice what I did through each process. I multiplied 3x times negative 2, got me negative 6x, and then the square root of 3x times the square root of 2xy, 21xy is this, right here. And then I simplified each little part. Okay? Now, so now negative 6 times 3 is a negative 18. X times x is x squared, and then times the square root of 7y. And so that's the answer. All right, it looks complicated, but it's not, because it really involved a lot of things you already knew how to do. See, all this stuff here, stuff you've worked on in previous lessons. All right, so that's number 5. All right, so don't make it difficult. It's not difficult. All right, number 6. So let's look at number 6. So in number 6, I have this now. All right, so listen carefully to this. You have the square root of 8x to the 5th, y to the 4th, times the square root of 3x to the 7th, y to the 5th. All right, now notice I can multiply these two. I can write these two as 1 square root because the indices are the same. Square root, square root. Now remember how to do that. So that's not new. Nothing's new here. 8 times 3 is 24. x to the fifth. Now let's think about this. X to the fifth times x to the seventh. So remember, when you multiply like bases, you add exponents. 7 plus 5 is 12. So that's x to the 12th. Okay? Y to the fourth times y to the fifth. So here's what you're saying. Y to the fourth times y to the fifth. When you multiply like bases, you add exponents. That's y to the ninth. So that goes here. Now this is something you've had in a previous lesson. So you're going to say, can I simplify this? All right, well, let's rewrite this now as a product of separate square roots. So there's a square root of 24 times the square root of x to the 12 times the square root of y to the 9. All right, so notice what I'm doing. So the first thing I did was I wrote this as one square root. Okay? Then I'm going to use what we've learned previously. So to simplify this, I'm going to rewrite this as a product of square roots. And then the largest perfect square that goes into 24 is 4. So this becomes the square root of 4 times the square root of 6, because 4 times 6 is 24. I can simplify the square root of x to the 12, and that's the easy one, because 12 is divisible by 2. So that's just x to the 6. Now, 9 is not divisible by 2, so let's think about this. How can I simplify the square root of y to the 9th? Well, the largest whole number less than 9 that's divisible by 2 is 8. So this becomes the square root of y to the 8th times the square root of y. And so now this becomes the square root of 4 is 2, square root of 6, x to the 6th. The square root of y to the 8th is y to the 4th. And then square root of y. Now let's write this in a better way, because I know that I can rewrite these two as one square root. And so I'm going to have 2 x to the 6th, y to the 4th, so let's go in front. So 2 x to the 6th, y to the 4th, and then times the square root of 6y. And so that's the answer there. Okay? All right, let's go to number 7. So it's not that bad. It's not that difficult at all. Cube root of 4. So now that we're dealing with cube root now. Cube root of 4, x to the 6th, y to the 7th, times the cube root of 2x, y to the 8th. So I'm going to do the same thing we did earlier. So the way you want to do this, is first of all, you want to write as one cube root. So the cube root times a cube root, you can write as one cube root by just multiplying the radicands together. 4 times 2 is 8. X to the 6th times x to the 1st is x to the 7th. When you multiply like bases, you add exponents. Y to the 7th times y to the 8th is y to the 15th. So that's where I'm at. Now you're going to simplify this, and this is something you've had before, so very simple. So first of all, let's go ahead and rewrite this as a product of cube roots. So this becomes the cube root of 8 times the cube root of x to the 7th times the cube root of y to the 15th. And 8 is a perfect cube already, so the cube root of 8 is 2, because 2 times 2 times 2 is 8. Now, I can simplify the cube root of x to the 7th because 7 is greater than or equal to 3. But 7 is not divisible by 3, so we got to ask ourselves, what's the largest whole number less than 7 that's divisible by 3? And the answer is 6. 6 is divisible by 3. So I'm going to rewrite this as a cube root of x to the 6th times a cube root of x. 6 plus 1 is 7. Now let's talk about this. So I can simplify the cube root of y to the 15th because 15 is greater than or equal to 3. And this is the easy kind because 15 is divisible by 3. So the cube root of y to the 15th is just y to the 5th. Y to the 5th times itself 3 times is y to the 15th. Now let's go ahead and simplify this little part here. So I get 2. The cube root of x to the 6th, 6 divided by 3 is 2. So that's x squared. X squared times x squared times x squared is x to the 6th. I cannot simplify this because 1 is less than 3. So I was going to say the cube root of x and then times y to the 5th. Now I'm going to rewrite this better. So I'm going to put the cube root on the end. So I get 2x squared y to the 5th times the cube root of x. And that's the answer there. All right, so notice you're going to multiply first, write as one radical, and then simplify each little part. All right, and then let's look at number 8. So let me do number 8 on another sheet of paper. So this is going to be number 8. All right, number 8. So in number 8, I have the square root of 12 x to the 11th times the square root of 6 x to the 4th y to the 13th. So the square root of 12 x to the 11th times the square root of 6 x to the 4th y to the 13th. So the first thing you want to do is you want to see you're multiplying this square root times this square root. So you want to write as one square root using a product rule. And so that means I can write this as the square root of 12 times 6. Use your calculator if you need to. 12 times 6 is going to be 72. X to the 11th times x to the 4th. So remember you're saying this, x to the 11th times x to the 4th. When you multiply like bases, you add exponents. So that's x to the 15th. And then all you have is y to the 13th now. Okay, so that's where I'm at. So now we want to simplify this though. So now you're going to rewrite this as the square root of 72 times the square root of x to the 15th times the square root of y to the 13th. Now let's talk about the square root of 72. The largest perfect square that goes into 72 is 36. So I'm going to write this as the square root of 36 times the square root of 2. Now I can simplify the square root of x to the 15 because 15 is greater than or equal to 2, but it's not that easy because 15 is not divisible by 2. So let's ask ourselves, what's the largest whole number less than 15 that's divisible by 2? And the answer is 14. So I'm going to rewrite this as the square root of x to the 14th times the square root of x. 14 plus 1 is 15. Let's talk about the square root of y to the 13th. I can simplify this because 13 is greater than or equal to 2, the index, but it's not divisible. So I'm going to have to deal with it the same way I dealt with x to the 15th. What's the largest whole number less than 13 that's divisible by 2? And the answer is 12. So I'm going to rewrite this as the square root of y to the 12th times the square root of y. 12 plus 1 is 13. So all this became this. So now let's simplify as much of this as I can. I know the square root of 36 is 6. I cannot simplify the square root of 2. I can simplify x to the square root of x to the 14th. That's just x to the 7th. 14 divided by 2 is 7. X to the 7 times itself is x to the 14th. I cannot simplify the square root of x. I'm going to rewrite it. I can simplify the square root of y to the 12th. That's y to the 6th. 12 divided by 2 is 6. And I cannot simplify the square root of y. Rewriting this better. Now, I want you to notice this. See how you have all these square root of 2, square root of x, square root of y? So you can write as one square root. So you always want to put it as one square root. Anything that's not underlined, I'm going to put in front. So 6, x to the 7th, y to the 6th, times the square root of 2xy. 2xy, just like this. And that is it. All right. So there's one, so that's 8 problems that should help you with that worksheet. So there's a worksheet that's going to look just like this, and it's going to ask you to multiply. All right. But notice almost all of what you have to do is information you've had in a previous lesson. All right. See all this right here? All this right here was from previous information. All you got to remember in this lesson is that when you have a cube root times a cube root, you can write as one cube root just by multiplying the radicands together. And then the rest is information you've had before. All right. Okay. So that's going to help you on that worksheet. So let me go ahead and end this video.